So 3.2, we will focus in today, which is the truth table. So before we do in the truth table, we touched base on this item last time. But before we do the truth table, this is the one thing that we need to know is you need to know what is the symbolic. Like I mentioned to you guys, the negation, the symbolic for negation is the tilde. And what is the true value or what is the true table relate to the negation? Well, the true table for negation is basically the opposite value. If your statement is a true, the negation will be false. If your statement is a false, the negation is true. And your conjunction, which is the and statement, your conjunction is the and statement, which is your symbolic, is the caret sign or the upside down V. And the truth table for the book, and you will see later on, I will tell you a little bit different how I remember it versus the book. But I just give you the book method right now. The book tells you that in order for a conjunction to be true, the only time that the conjunction is true is when both of the statement is true. Okay, so if it's not both of them is true, the conjunction, the and statement will be false. Okay, so the and statement, the conjunction, both of them to be true in order to be true. The result true only when they both are true. If you don't see both of them true, the result will be false. And the book tells you the disjunction, which is the or statement, which is the right side V. The or statement tells you that the only time the or statement is false is when both of them are false. If you see, the only time the or statement is false is when both of them are false. And this is the one time, the one and only time that the order matter is the conditional statement. The conditional statement, this is what they tell you is the only time that is false. The only time that is false is when the first item is true and the second item is false. And this is the only time that you have to look at the first item first, meaning whatever on the left of the arrow, you have to look at first. And whatever on the right of the arrow, you need to look at second. And this is the one time that the order matter. And lastly, the if and only if, the biconditional statement, which is the if and only if. The if and only if, which is the double arrow. And the double arrow, you need to have two of the same. If they both true, the result is true. If they both false, the result is still true. Okay. The only time that they are true for the biconditional statement, think in terms of bi meaning two, you need two of the same. So that is what we have in terms of the criteria of the truth table. And one thing I want to point out to you guys is the and, the or, the if and then, and the if and only if. In order for you to find the result, you have to look at two columns. And the maximum column that you will looking at, ladies and gentlemen, the maximum column that you're looking at is 2. That's it. You will never compare 3 at once. At one particular time, you only compare 2 columns at a time. And the negation, the only thing that you do with the negation is you look at 1 column at a time. Okay, so this is what the books say. This is what we have. And one thing, as we get to the next set of problem, and like I said, today our goal is to hopefully get you to be able to know how to start on your truth table and how to end your truth table. And in order for you to start with the truth table, you have to know your symbolic. There's no way out of this chapter 3 without knowing the symbolic. This is the 5 and only 5 symbolic that you have. The negation, the conjunction, the disjunction, the conditional, and the biconditional statement. Okay. And once you know criteria and their name, right, their respected name and their symbolic, once you know the symbolic, you have to know the criteria of the truth table. So let's take a look at the example. Let's take a look at the first example I have. So this is probably what you will see on your homework. This is probably what they give you is construct the truth table. They tell you just construct the truth table. Doesn't matter what P is, doesn't matter what Q is, right? P can be I'm going to work, and Q can be my car broke down. Doesn't matter what the sentence is, right? So this is all they ask you to do is construct the truth table for A, B, C, and D. So let's take one thing at a time. And if you did the homework, or if you do this by hand on the piece of paper, the first thing you want to do, or the first thing is, this is the fixed truth table. This truth table will always be the same for any P and for any Q. We want to keep it consistent. Your P will always be true, true, false, false, and your Q will be true, false, true, false. The reason is, last time I told you that this is all of the combination of true, false you can get when you have two items. So for me, this is what I tell my student is, and because of the structure of class we are in, on your homework, when you look at this thing here, your homework gives you the P and Q. So for A, we only have PQ, so this is all we needed, okay? And basically, ladies and gentlemen, this is your starter kit. This is your beginning of the truth table, okay? And that's why when you do the homework, your Alex will always give you this thing at the beginning, okay? So once we have this as the starter kit, this is our beginning. This is what you need to ask yourself. What is my connector? Do you agree that my connector for A is this right here, the conjunction, the and statement? In order to do this and statement, I need to know what is P, and I need to know what is the negation of Q. Those are the two items that I need to have in order for me to connect them together. Okay, so first of all, in order for me to connect them, I need the two things on the side. Everybody see that this is my connector. My connector is this item. And again, if you remember, if you have your cheat sheet, your connector, the and statement, the conjunction is the only time that is true is when both of them are true. But before we can do this connector, everybody see that this is what you need to ask yourself. Do you have the P? In this case, everybody say, I got the P. My P is right here. Whatever this column, that is my P column. Do I have the negation of Q? Well, from this starter kit, I don't have it. I only have Q. I don't have the negation of Q. So whatever you don't have, everybody see that if you don't have it, you can insert them in. You can create them. You can find the negation. Because how do I find the negation? What is the negation? Do you agree that the negation tell me this? I don't care about the negation tell me this. Whatever Q it, and this is the operation I'm working at this column here. I'm working at the negation of Q. Whatever Q it, I need to take the opposite. So I don't care about P. I just look at Q because I only need the negation of Q. So if true, the negation of Q will be false. If Q is false, the negation is true, and vice versa. So everybody see the negation is that easy. The negation, in order for you to do the negation, you just look at one column. Whatever the column they ask you, you look at that column and you take the opposite in value. And that's why in the previous slide, I told you that the negation is just the opposite value. So the negation of Q is whatever Q is, we take the opposite in terms of the true value. So question here in terms of the negation of Q here. And to go back to my problem, everybody see that I got this. I got my P. My P is this column. I got my negation of Q. My negation of Q is this column, meaning, again, I don't need this column. Whatever this column is, I don't care. I don't need it because I only need the two things on the side for me to do this operation. And like I mentioned in the earlier, when you connect something, you only look at two columns at most. You have to ask yourself, what two columns am I looking at? So everybody see at this column here, I'm working on my connector, and my connector is a conjunction, which is the and statement. And if you look at the note from last slide, the and statement tell me that in order to be true, the conjunction, they need to be both true. In order to be true, the two items have to be true. If they are not true, then the result will be false. So the conjunction, the and statement is the only time that is true. The only time the result is true is when both of the statement, or in terms of this, both of your column is true. If they are not the same in terms of the true, meaning if they have one false, the result is false. Okay, so the only time it's true is both of them are true. And this is your answer right here, which is, if you did your homework, if you did your homework, Alex basically tell you to put this thing in. And if you put this thing in on Alex, they will tell you it's right. This thing here, probably you don't need it. But to go back to this item I have, this is my answer for A. P and not Q will be false, true, false, false. Okay. So question here with this conjunction, with this and statement, or how did I derive from my starter kit, how did I derive to this item here? I agree that from this starter kit, from the PQ, which is, as you see, all of this thing here, from PQ will always be true, true, false, false for P. Q will be true, false, true, false. So question, how can I took this starter kit and come up with this result here? Just like, just like in any math, take one step at a time. Ask yourself, don't look at the whole item. Take one step at a time. Same thing go, looking at this B. Do you agree that this is my connector? My connector is the and statement, no, the or statement, the disjunction, the or statement. And if you remember, the or statement say the only time that is false, the result is false. Okay, so this is what you ask yourself is, do you have from this starter kit, this is your starter kit, this is your starter kit, from this starter kit, just looking at this item here, do you have the two things on the side? I don't have this item. Do you agree that I don't have the negation of P and I don't have the negation of Q? I don't have it on my starter kit. My starter kit just have the P. My starter kit only have the Q. But the negation is easy to do because why? The negation, do you agree that I can find the negation of P? And the negation of P is easy. Whatever P is, the negation will be the opposite. So P is true, true, false, false. The negation of P will be false, false, true, true. Whatever P is, again, if you confuse, just block what you don't need. I'm looking for the negation of P, which is, this is my P. The negation tell me whatever P is, I'm going to give me the opposite of P, which is, if it's true, the opposite is false. If it's true, the opposite is false. If it's false, the opposite is true. If it's false, the opposite is true. And that's what the negation is. Look at that one column. Look at one column and give me the opposite in value. And similarly, I can find the negation of Q. And the negation of a Q, just like before, let me just block the thing I don't need, because the negation tell me just look at one column. And what column am I looking at? I'm looking at the Q column. So the Q column is this, which is true, false, true, false. What is the negation? Well, the negation will be false, true, false, true. So everybody see that how we find the negation. If you find a negation now, do you agree that I got this? If you look at my table, we got this, ladies and gentlemen. We got the negation of P, which is negation of P is here. We got the negation of Q, the negation of Q is here. And now what do? Well, we can find the disjunction. And what is the disjunction? The disjunction tell me that, take a look at that two column. The disjunction tell me that the only time that is false, if you look at the rule, if you look at the criteria, they tell you that the disjunction, the or statement is the only time that is false is when both of them are false. Everywhere else, if it's not both of them are false, it will be true. And that's what we have in terms of the conjunction and the disjunction. So if you in doubt, like I say, whatever connector you doing, you only look at 2 column, compare the 2 column at most. Make sure to know which column you compare to. And if you don't have the column you needed, you can always insert them in. Okay. So let me see. Someone typed something on the chat. So one thing is, I tell my student, if you took me in class, or if you, the definition I give you earlier is the book definition. For me, if you don't like the book definition, if you don't like the book way, and again, for the book, for the and, the only time it's true is when both of them is true, everywhere else is false. The only time the or is false is when both of them is false, everywhere else is true. The other way, on the other side of the spectrum, you can look at this is, for me, the and statement, the conjunction, as long as I see a false, the result is false. For me, the and is as long as one of them, doesn't matter which one, as long as I see a false, the result is false. So you can see that way, looking at this item here. Remember, how did I come up with this answer? Well, I'm looking at this column. And as long as I see a false, everybody see I see a false here, the result is false. I see a false here, the result is false. I see a false here, the result is false. Doesn't matter which one. In this case, and again, for this two, I don't see a false, so it's true. So that's my and statement. For me, that's how it's easy for me to remember. I don't know if it's easy for you to remember, but you have to pick and choose. You either choose my way or you choose the book way. Don't mix and match them together. Choose one way and just remember it. And like I mentioned, chapter 3 is a lot of memorization, okay? And for me, for this item here, for the or statement, for me, for the or statement, this is how I remember it. For the or statement, as long as I see the true, the result is true. Doesn't matter where, as long as I see one T. For the or statement, as long as I see one T, the result is T. So again, that's how I remember it. For the and, as long as it's the F, the result is F. For the or, as long as I see an T, the result is T. So it's up to you. It's up to you. You can use the book. You can use the book method or the book way to remember it, or you can use my way. But you have to pick one way to remember. And I will mention it more when we question. So, question?
Mr. Chang?
Yes.
Yeah, I was trying to, like, just to get a clearer understanding, for B, that statement is true because we worked out the truth table.
We are not looking for the true or false anything here. We don't know what this statement is. Our goal is, if we have some statement, can we derive it to the final statement from the final answer? So the combination of this thing, this is not a true statement because there are some false in it, okay? The next one, you will see that there, how can the statement is true next time, but next slide. But this one here, we are, in the sense that we are not looking for the trueness of the statement here. We basically, if we have some statement, can we justify using the symbolic to know if we derive to a true or to a false? Because again, because right here, clearly there are some false in this statement. So this statement, in order to be a true statement, all of them have to be true, okay? But there's some false in here, so that's not a true statement, meaning there's somewhere you can disprove this statement, meaning there are some occasion that this statement can be false, okay? And the next slide, the next example, you will see how can a statement is a true statement all the time, okay? But for now, the goal is hopefully you can look at the symbolic and you can identify what is the criteria for that symbolic. And that's why in here, I give you the and, the or, the if and then, and the if and only if, which is those are the 4 connectors we have. And on top of that, we have the other negation that we need to do. So right now, we won't do any true or false statement as of now. When we get to 3.4, that's when we need to do when we put all of that together. But for now, we just want you, if I give you whatever symbol I give you, can you come up with a truth table?
Okay.
Okay.
All right. Thanks.
All right. So let's take a look at C. And again, C's look very massive, right? We have the negation of the parenthesis. And one thing, ladies and gentlemen, for the negation of parenthesis, please do not distributive anything in. Just like algebra, if you have a parenthesis, you want to work inside your parenthesis first. Don't worry about this negation. We do it a little bit later, okay? So looking at this item, as always, we look at C and we can see that I have only one connector. There's a lot of symbolic, but there's only one connector, and the connector here is the if and only if statement. And if you have the connector, everybody see that my starter kit, this is my starter kit, PQ. And do I have the two things on the side? I got the Q is here, but I don't have the negation of P as of now. Do you agree that on my starter kit, I don't have the negation of P? And just like before, just like A and B, whatever the negation is, we can find the negation because the negation is the easiest thing to find. Whatever P is, we need to find the negation, which is P is true, true, false, false. The negation will be false, false, true, true. And once we have the negation of P, everybody see that, yes, I got this. I got the negation of P, which is the negation of P is here. So what are the two columns am I looking at? So, if you in doubt, just block it out. Block what you don't need, right? You only need two columns at most. Whatever the connector is, you only need two columns at most. Maximum is two columns. You only compare two columns. So if you want, just block out things that you don't need so that you won't confuse yourself. And now, once you block it out and once you say, yes, I got the Q, I got the negation of P, now this is what you need to ask yourself is, what is the criteria for the if and only if? And reminder, the double arrow, the criteria for the double arrow is in order to be true. In order to be true, the result true, both of them have to have the same value. In this case, do you see that this thing does not have the same value? The TF, the result is false. Both of them is true. Both of them is false. Because they have the same value, the result is true. Because they have the same value, the result is true. If they don't have the same value, the result is false. And that is your if and only if, your biconditional statement. And biconditional statement, we need two of the same. And that is why this item is true, regardless if it's false. Both of them is false, the result is true. Both of them is true, the result is true. Biconditional, two conditional, in order to be true, two of them have to be the same. So question here in terms of, this is your answer. If they ask you this question, well, not your answer. Question here in terms of the criteria of the if and only if. So if you can see, we're done with this, right? We done whatever this item, whatever in the parenthesis, I got it. Whatever in the parenthesis is right here. But we are not finished with the question, because the question, they turn around and say, whatever you just did, I want the opposite of that, right? We're not finished, because in terms of this thing here, we have to finish the whole item, which is the negation of the parenthesis. So do I have the thing in my parenthesis? I did. That is the thing inside my parenthesis. Whatever in my parenthesis is, I don't look at the individual anymore. I look at the whole thing. And my whole parenthesis, do you agree that my whole parenthesis is this column right here? Whatever in my parenthesis, the negation of P, if and only if Q, is this column right here, which is false, true, true, false. And then they turn around, they say, that's good that you just find the parenthesis, but I want the opposite of that. So what is the opposite of that? I don't care about the other 3 columns. I only care about this column. And that's why I mentioned to you, whenever you do the negation, you only look at 1 column, and all you need to do is take the opposite, right? If it's false, the result is true. If it's true, the result is false, and vice versa. So in this case, the only time you look at 2 columns, the only time that you compare 2 columns is whenever you work with the connector. If you work with the negation, you only look at 1 column at a time. Whenever your negation, whenever you try to do your connector, you look at 2 columns. Everybody see the difference between the negation versus the connector, and how do we find the connector, or how do we find the negation question here? And like I say, like I told you guys, the hardest thing for chapter 3 is how to know your notation. How do you know your symbolic? And once you know your symbolic, on top of the symbolic, you have to know the criteria of each symbolic, okay? So, and hopefully you guys see A, B, and C, when we do the connector, when we do the if and only if, when we do the and when we do the or, I did not mention anything about the order, right? For the and, for me, to remember my and is, as long as I see a false, the and statement is false. For me, the or is, as long as I see a true, the or statement is true. As long as I see both of the same value, the statement is true for the biconditional statement. If I don't see the same value, the statement is false. I did not mention anything about the order. And this, for D, this is the one and only time we need to have an order. What does that mean? Meaning whatever on the left, you have to look at first. Whatever on the right, you need to look at second. The first thing have to come first, and the second thing have to come second. So let's construct this truth table. We know our starter kit. Our starter kit is this, because as long as I have PQ, I have PQ. This is my starter kit. True, true, false, false for P. True, false for Q. And I ask myself the same question. Do I have the 2 things on the sides for me to do this connector? I got only 1 item. I don't have this item, and that item is easy for me to do. I need the negation of Q. How do we find the negation of Q? Whatever the Q column is, I take the opposite value. The Q is true, false, true, false. The negation of Q will be false, true, false, true. So here come, ladies and gentlemen. You will see me do a little bit different here, just to show you. Looking at this item, like I mentioned, in order for you to do this connector, everybody see we got the 2 items we needed. We got the negation of Q and we got the P. But to do this connector, you have to look at the first thing first. So what is the first thing? The first thing is the negation of Q, meaning you look at this item going, this ANOVA is not good. You have to look at this item going that, this. You have to look at this item. Okay, give me 1 second here. I get it. I will eventually get this. So you have to look at, negation of Q going back to P. Everybody see that we have to look at this item going that way, meaning whatever comes first, we have to look at first. What is the first item I have? The first item I have is the negation of Q. So I have to look at the negation of Q first, and this, ladies and gentlemen, is the only time. This is the only time that you have to look at the order, or the order matter. So for me, this is what I tell my student is, for me, to make it easy on myself, whatever comes first, I just put it first. Whatever comes second, let me just move my Q. Because I have my P in the second item here, I just move my P, whatever the P is, I just move to the right, so that looking at this particular item, I don't need to tell myself that, oh, I need to go backward, okay? So you can do this if you want to. Basically, whatever on the right, just put it on the right. Because for now, if you look at this way, you can see that all we need to do is just look from left to right, left to right, left to right. Everybody see that this here, this is the only time the order matter, meaning whatever comes first, you have to look at first. Whatever comes second, you have to look at second. And this is the only reason why I move my P to my right, because whatever on the left, I look at first, and whatever on the right, I look at second. So now we know that I have the two things that I need. I have the negation of Q and I have the P. Now I can do this if and then statement. If and then statement, if you remember, if and then statement, this is what you have. They tell you the only time that the if and then statement is false is the first thing is true and the second one is false. This is the only time that is false, is the first thing is true and the second one is false. If it's not in this sequence, if it's not in this pattern, if it's not exactly this way, the first thing is T and the second one is F. If it's not in that form, then it's true. The only time that is false is in the form the T, error, and F. The first thing is true and the second one is false. Okay, so this is why for me, if you don't put the P here, if you don't put the P here, it's not wrong if you put the P. If you don't put the P here, everybody see that if you don't put the P here, you have to look at this way. You have to look at in terms of, you have to look at the negation of Q going back to the P. You have to look at this way going backward. And a lot of students make mistake is they don't go backward. They don't look at the negation of Q going to P. All they do is they look at P going Q, P going Q, P going Q, P going Q. Okay, so you have to make sure, put a note, put a store, put a highlight, whatever you need. Just know that one single to the right, the if and then statement, the conditional statement, the order matter. And if the order matter, you have to look from left to right. And whatever comes first, you have to look at first. Whatever comes second, you look at second. And the one time that is false is the first thing is T and the second one is F. If it's not the first thing is T and the second one is F, the result is true. Okay, so that's the criteria for the if and then statement. And somehow the if and then statement, the conditional statement, is the one statement that give you guys a lot of problem. So question with this 3 or 4 or 5 criteria. You know, I purposely give you this example on this slide to show you the and statement, the or statement, the if and only if statement, and the if and then statement, which is those are your 4 connector. So question with this A, B, or C, or D here. So hopefully you have a better understanding of how to construct the truth table. Let's take a look at this item further, right? Let's take a look at this item here. What if they combine more than one connector, right? The previous slide, we have each problem A, B, C, and D. Each problem have only one connector. What happens if now we have multiple connector? And as you can see, we don't have any new connector. This is if and only if and then. This is the or statement. This is the and statement. This is the if and only if. This is the if and then. And this is the and statement. As you can see, we don't have anything new. There's only 4 connectors that we're dealing with. And the 5th item is the negation. Okay. So if you were to have this thing here, don't let it intimidate you. This is what you need to ask yourself is, what is my starter kit? And on Alex, for you guys, Alex help you. This is your starter kit. Your starter kit, whenever you construct a truth table, you will always start with P true, true, false, false, Q, true, false, true, false. And that will always be the same. We want to keep it consistent, as much consistent as we can. And this is the consistent part of the truth table, is the starter kit. Now, let me ask you, or when you do this thing here, do you agree that we have two connectors? You can disagree, but you will be wrong. Just kidding. You have two connectors, right? You have the if and then and the or connector. So before we can do the if and then, everybody see that before we can do the if and then, in order for me to do if and then, I should say, I need the P, which I got the P, and I need whatever this parenthesis is. Whatever in this parenthesis, I need a column that have that parenthesis. So if you look at this thing here, we cannot do the if and then statement. So if we cannot do the if and then statement, just like before, we need to do inside your parenthesis first. So inside your parenthesis, just treat one item at a time. So this is what we want to do. We want to do inside the parenthesis, and inside the parenthesis, do I have the two things on the side? I got this item, I got the P, but I don't have the negation of Q. So you can see if we do the thing in our parenthesis, it's just the same as the previous problem. We need to do the negation of Q first. And hopefully by now, the negation of Q is the same, false, true, the opposite of Q. And once you have the negation of Q, we got this item. And if we have that item, do you agree that now I don't need this column? And like I mentioned to you guys, if you want to just block what you don't need. So this is the two things I need. I need the P or not Q, the disjunction. And if you remember the or criteria, you can either say, this is how I remember, guys. This is what I remember, or this is what I told you. For me, for the or statement, the right side U, the right side V here, the or statement or the disjunction, as long as I see a T, doesn't matter which one, between these two, as long as I see one T, the result is a T. As long as I see one T, and if it's two, it's fine. But as long as I see one T, the result is true. So that's how I remember for the or statement. As long as I see a T, the result is true. As long as I see one T, doesn't matter the first one or the second one, as long as one of them is a T, the result is true. Okay, you can remember that way, or the book tells you the only time that is false is when both of them is false. So again, it's either or. How you remember it is up to you, but your goal is you have to remember it. When you take the test, you don't have the cheat sheet with you. You have to learn somehow, some way to remember this, okay? So either see that the or statement, as long as there's a T, the result is true, and or you can say the other way. So once I have this item here, do you agree I'm done with the parenthesis? Whatever in my parenthesis, that is right here. This is the item inside my parenthesis, P or not Q. And now, do you agree that we have the two items we needed? We have the parenthesis right here. We have the P right here. And now we can do this connector. We can connect this item together, which is the if and then statement. So if we connect that item, let's block the thing we don't need. We don't need those. And if I can connect them together, do you agree that this is what I need to do? Is I need to look from left to right. And if I look from left to right, remember the criteria for the if and then. The only time that is false is the first thing is true and the second one is false. So in this case, this is what we have. The criteria for if and then is the first thing is true, error, the second one is false. This is the result of false. So do I have any, the first thing is true and the second one is false? As you can see, the first thing is true, second one is true, the result is true. The first thing is true, second one is true, the result is true. The first thing is false. Is not follow this pattern. The pattern is the first thing have to be true and the second one have to be false. If the first thing is false, it's automatically true. It's automatically true if the first thing is false. So again, this is what you need to ask yourself is what is the criteria? And this is the one and only time that the order matter, ladies and gentlemen. The one and only time the order is matter. And the first thing you have to look at first, which is my first item, is the P. And the second thing is my parenthesis is here, so I look at from left to right. Question with this if and then statement. And if you don't have question with the if and then statement, ladies and gentlemen, if you look at this result here, and Tanya, since you asked the other question earlier, this is a true statement. Meaning no matter how you try to bend it, the result will always be true. So this here, you will see that in 3.3, we call this a specific or special name. If your final result come out to be all true, like this case, no matter how you bend, no matter what the circumstance is, the result is true, right? Meaning this thing here is a tautology, and the tautology is basically tell you that your statement, whatever your statement is will be true. Okay, and this is where your true statement come in. The previous 4 problem, we have some false, meaning there are something that you can bend to make it a false statement, and that's why is not a tautology. Okay, but don't worry about tautology now. We'll mention more about tautology later. About tautology when we get to 3.3. But for now, our goal for here is if we give you this item, can you navigate your way out of it by, well, not out, but can you navigate your way to construct the truth table? And to navigate anything, just take one step at a time. Don't look the whole thing as a whole item, right? So let's take a look at B, and then I will stop and ask you have question, because B is the other 2 connector. The first one is the if and then this is the or. B is the and the if and only if, right? So let's take a look at B. And if you look at B and if you start B, your starter kit, your first steps is this item. And it's always the same. We want to keep it consistent, and this is the most consistent that we have is the P and the Q. Now, what do? We basically, whatever we need to do, basically we have to do inside the parenthesis first. So don't worry about this item here. We need to do inside the parenthesis. And now, do you agree that inside my parenthesis, my connector is the and statement, the conjunction? And a little bit good thing for us, the conjunction, and we have the 2 things on the side. What are my 2 things on the side? Well, I got it, the P, Q. So my and statement for me, ladies and gentlemen, for me, my and statement, the way that I remember for the and statement, the upside down V here, the conjunction, as long as I see a false, doesn't matter where, as long as I see one false, the result is false. That is how I remember my and statement, my conjunction. For me, the book say the other way. The book say the only time it's true is both of them is true. You can understand that. You can either remember that the only time the and is true is 2 of them is true. If it's not 2 of them is true, it's false. For me, to make my life a little bit easier, I say the and statement as long as I see a false. As long as I see a false, the result is false. As long as I see a false, doesn't matter where. As long as I see a false, the result is false. And again, both of this thing here, the result is false. So that's how I remember. However you remember is your call, but you have to remember there's no way out of it. Okay. So I got the thing inside my parenthesis, but they turn around. They tell me whatever you got in your parentheses, give me the opposite. So this is the first term, which is the opposite. What column am I looking at? Hopefully you guys see that we look at the third column. We don't care about the first two. We only care about the third column. They just tell me take the opposite of this. And the opposite of this thing here will be false, true, true, true. Basically, whatever this thing is, we're looking for the opposite. So I'm done with the first item too, right? Whatever this item is, I got it, guys. Whatever this first part is right here. That's my first part. Now, what do they tell me to do? They tell me to take this first part and compare that to the if and only if not Q. So if you look through your item, you did not have any individual not Q. You did not have any individual not Q. You don't have a column of the individual of negation of Q. So if we don't have it, we insert them in. And if we insert them in, what is the negation of Q? The negation of Q is whatever Q is, we take the opposite. By now, hopefully you see that the negation, we only look at one column. Whatever Q is, we take the opposite. The opposite of Q will be false, true, false, true. So in this case, we got the two things we needed. We got the two things we needed. And what are the two things we needed? And about see the two things we needed is this item here and the negation of Q. So can I do this connector? Can I do the if and only if connector? And hopefully you guys see that if and only if connector, in order to be true, they need to have the same value, right? Two error. In order to be true, they need to have the same value. If they don't have the same value, the result is false. And this is my result. This is my final answer. True, true, false, true. And as you can see, this is not a true statement. This is not a tautology. The reason is there are something that you can bend. There are something that you can disprove this statement and it's become a false statement. This up here, there's whatever you try to bend, whatever you try to disprove, the result is still true. This thing here, there are some way that we can disprove this item and it's come out false. We mentioned that more when we get to 3.4, but for now, let me stop and ask you guys question on where the step, question on where the criteria, or question on any of the item on the screen right now. And again, hopefully, no, after you've seen this, is a little bit better. It's a little bit better. I know some of you guys did the homework, and when you come to the truth table, you kind of confused and kind of hesitant, or is the first time you see it is pretty much our proportion, right? It's not harder than it's look. I mean, it's harder than it's look, right? But hopefully after this lecture, you guys are more confident of doing the truth table. So let's finish this up. Let's do C. And one thing I want to point out to you guys, ladies and gentlemen, Alex is a little bit different. If you did Alex, you see that they have the gradient part and you can insert at many. Basically in Alex, none of this thing count. This item right here does not count. All they ask is this item that they have. And then you can press the plus item. You can click on the addition sign and they add more column for you. And you can insert whatever you in there and they say that would not count as a grade. So the only thing that they count as a grade is the final step. So if it's easy for you guys, I suggest you to do it on paper instead of do on Alex computer. Instead of doing computer and computer, your eye would trick you. When you look TF a lot, your eye will trick you and you look at the wrong item. Do it on your scratch paper, do it in your notebook, do it somehow on the piece of paper, and then just type in the end result as they want it or as they need it. That should be a little bit easier on your part rather than try to do it. For me, I type it up here because I can only show you as I type it up. But when I construct this slide, I kind of have to write it down and then type it in, but to make it easier and mistake free. But try to do it on the piece of paper first and then type your answer in the computer rather than do it on the computer, because you know how tedious Alex is. If you do one wrong thing, they will bring you back to one problem. So again, and then if keep on bringing you back, you get frustrated. But let's take a look at this item. I do a little bit different here. For this particular problem, I know that you guys say, wait a minute, Mr. Tran, why did you not do inside your parenthesis first? The reason why I did not do inside my parenthesis is because I know that this operation here, the if and then statement, the order matter. So I want to have whatever on the left first, and whatever on the right, I do it on the right. So that's why I do the negation of Q first, okay? So the negation of Q, and negation of Q is easy by now. Hopefully you know the negation of Q is just the opposite of Q. So once I have the opposite of Q, I can work in my parenthesis. Hopefully you guys say, yeah, we can do inside a parenthesis. Why? Because we got the P and we got the Q. And now what do they ask me? Well, they ask me P and Q. Upside down V, this is the and, this is the conjunction. And the and for me, as long as there's a false, doesn't matter which one, as long as one of them is false. And again, try not to confuse yourself. We are not looking at this column. We only look at the P column and the Q column. So as long as there's a false, in this case, you can see, as long as there's one false, the result is false. So the only time it's true is both of them is true, which is the first item is true. Everywhere else is false. That is the and statement. And once I have the and statement, if you did the and statement first, you need the negation of Q. But the negation of Q, like I mentioned, this is the one thing that I want to do, is because the order matter. Because the order matter, I want to have whatever on the left first, and I look at from left to right. Again, the error, one single error is the one thing that you guys will get wrong a lot on Alex. You will get wrong a lot is this operation here or this connector, because sometimes you might look the opposite direction. Whatever on the left, you have to look at first. Whatever on the right, you need to look at second. This is the one and only time the order matter. So what do I do? Well, if the order matter, and what is the criteria? The criteria tell me this. The criteria tell me that if T error F, then the result will be F. It have to be in this sequence. It have to be in this exact sequence, which is, you can see we have a T, error, and F. So the result is F. The T, error, and F, and that the result is F. If it's not in this particular sequence, if it's not in that same exact sequence, then the result is true. Doesn't matter what the other sequence is. If it's not the first thing T and the second one F, the result will be true. The only time that is false is the first thing is true and the second one is false. First thing is true and the second one is false. The T, error, and F, the result is false. Okay, so question here. Question with this particular item or question with this particular side. Again, like I say, don't worry about tautology yet. I don't think they ask you about tautology in 3.2. I just make up an item and all of a sudden it's come out to be a tautology, and then I just want to mention it to you. So before I let you guys go, let me cover this. Let me cover this item so that if you happen to run across it, you know what they're talking about. The last thing I want to cover is the De Morgan law. And I believe the De Morgan law is in 3.3, but sometimes they sneak it in to 3.2. The De Morgan law is this, ladies and gentlemen. De Morgan, he came up with the law, and he tell you that these two items, the negation of the disjunction will be equivalent to the negation of the disjunction will be equivalent to the conjunction of each individual negation. Okay, so equivalent, this is what basically tell you, or whoever say, oh, Mr. Strand, can I distributive my negation in? Well, De Morgan law say, yes, you can. You can distributive the negation in. It's just that you need to change your connector. From the OR connector, you need to change it to an AND connector. And these two items will be equivalent. Vice versa, if you distributive your negation in, the AND statement will become an OR statement. So basically just tell you that the negation of the parenthesis, the negation of the conjunction, which is the AND statement, will be equivalent to each of the negation, disjunction of each of the negation. So basically tell you that if you want to distributive them in, whoever wants to distribute them in, you can. You just know that for the AND and OR, you need to reverse you need to change the operation. So let's take a look at what does it mean logically equivalent. Why do I underline the logically equivalent? So this is what we have. Let's take a look at this item. Let's say if I ask you on the homework, on the quiz, or on the test, let's say if they ask you construct this truth table. Do we know how to construct this truth table here? And hopefully now with confidence, you guys say, yes, we can, right? All they have is one connector, and this is the OR connector. And hopefully you guys say, we can do this, P or Q. And P or Q, as you remember, for the OR, for the disjunction, as long as I see a T, the result is true. For the OR statement, for the disjunction, as long as there's one T, doesn't matter where, as long as one of them is T, the result is true. So I got the disjunction, I got the OR statement. And now they turn around and they say, very good, you did it, but I don't want it. I want the negation of that, right? Whatever you did, that's very good, but now I want the negation of the conjunction or disjunction in this case. So what's the negation of this item? Well, the negation of this item, just like before, my parentheses here, the negation is basically the opposite. So the opposite of true, 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 false will be false, 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 true. So that is what I have in terms of the first. If I were to ask you to construct the truth table for this. Now, let's say they go in around and they say, construct the truth table for this. So let's do another truth table. So if we were to construct this truth table again, this is what I have. And we can see the AND statement, the AND connector, that is I need to do the AND connector. And to do the AND connector, I need a two item on the side. That's why I need the negation of P for false, true, true, negation of Q for true, for true. And once I have that, do you agree that I can do my AND connector? My AND connector tell me as long as I see a false, doesn't matter where, as long as I see one false, the result is false. So in this case, everybody see that we have false, 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 true. And this, ladies and gentlemen, if you look at this item here, when you construct the truth table, whatever truth table you have, as long as the final product is exactly the same, everybody see we have exactly the same here, false, false, true, false, true, and false, 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 true. If that's my final product, as long as they are exactly the same, we say that they are logically equivalent. And that's what logically equivalent is. They basically tell you that if you want to distribute your negation in, your operation, or in this case, your connector have to switch the direction. And again, that's what they tell you that is equivalent, okay? So in order to know if it's equivalent or not, you need to construct your truth table and look at the final result. If the final result exactly match line per line, it has to be matched line per line. If they match exactly line per line, we say that they are logically equivalent. And that's what De Morgan law proved. The De Morgan law, or the guy called De Morgan, he proved that these two items are equivalent, okay? If you distributive your you distributive your negation, your operation need to change from the and to the or vice versa, from the or to the and. Okay. So question with this particular De Morgan law here. We will mention more De Morgan law next time. We will do a little bit advanced in De Morgan law. And I think next time when we do a De Morgan law, we have to translate to English. So